In this video, we will be connecting to the AMSA vessel tracking dataset and creating a map. So this notebook analysis is from 2012 to 2025. So before we proceed ahead with the analysis, please make sure to download the latest notebook from our public Git repository. So this notebook is structured in 3 parts. In the first part, we will be looking at connecting to the NESP datasets, and in the second part we will be looking at some S3 aggregations and mappings, and in the third part we will be analyzing some trend sites. So here are the 5 NESP datasets. The first one is AMSA, then kelp, NRMN, seabird, seagrass, and here is a link to all these datasets which is on our S3 public repository, that is data uplift public, and here is the directory path to each of these datasets. So as you can see, the AMSA dataset is partitioned because the dataset is quite huge and has approximately 200 million records, so it's easier to analyze this dataset in chunks. Now we will be looking at the required Python packages that you need to install in your machine before running this notebook. So we will have a brief about these packages before going further ahead in this notebook. The first one is UV installation. So UV is a very nice tool, you can say, which helps you manage your Python versions, environment, and projects. And it is very efficient in managing all these dependencies together and installs all your packages in just one click with just uv pip install dot. Next, we will be going with pip installations. It is again a Python tool which manages your Python environment. Then we will be going further ahead with this notebook, so you just need to run this Jupyter notebook command and you will be good to go with running this notebook ahead. Now this notebook has its own Python packages that you need to have in your machine installed for running this notebook through without any errors. So let's look at the packages that you need to have installed in your machine so that you are good to go. So the first one is PyArrow. It's a very efficient package which is useful in reading and writing your large data files. And then we have Polars. It is very nice for computation and manages to transform or analyze large volume of data. Then we have PyDeck, and it creates interactive maps that you can use to analyze your spatial data. So next, for plotting, we have Seaborn and Matplot library, which helps create charts and analyze statistical visualizations. Also, we have this rich tool which helps you print your console outputs in a beautiful format. You can say, for example, the tables looks very easily readable by using this console output. So in the first step, we are just importing this console, rich console, and it's just nothing but just like a print statement. So as we discussed, we will be moving now to the connecting part of NESP dataset. So in this, we will be establishing our connection with our S3 bucket where our dataset is located using this file system. It's nothing but it just establishes a connection with S3 bucket. So you can see here anonymous equal to true, which means that you don't need any passwords and you can just access the data which is available publicly. Then we have established a connection to the dataset, and it doesn't load the data yet. It just establishes a connection with that dataset in that public bucket. And then you can see over here that we have used this dataset in order to print its schema using Rich Console. And before, so you can see that we have used our utility library that we created. In order to go through this library, please look at our other video which goes through this library functions in more detail. So over here we are just using its print schema rich table in order to print the schema of the AMSA dataset. So you can see how beautifully it prints on our screen, and we have our craft ID, which is our vessel ID, and it's a unique identifier for each vessel. Then we have our lats and longs and some vessel related information. Then our H3 index. We have pre-calculated this index on resolution 8, and these are some Australian marine tags with respect to the lats and longs, which are pipeline separated over here. So now let's move ahead, where we will be loading our data with respect to the lazy data frame, lazy frame. So what it does is just, it doesn't read the data yet, but it just keeps it over there and loads it or creates a plan where it will load it when it just clicks .collect. So over here it just creates a lazy frame but doesn't load it yet.